Okay, here's the solutions to the first prep on the sine rule and cosine rule. So, first question, triangle ABC gives us the lengths of AB and BC and this angle that is in between these two sides. Part A, calculate the area of the triangle. Now remember that the area of the triangle is a half times AB times sine C. Now, in this case, sides are this side, and the angle between them is this angle. So our area is a half times one of the sides times the other side times the sine of the angle between those sides, which of course is 67 degrees. So when we've done that, we can add that to the calculator. So let's just get a calculator up here. And I'm just going to check that this is in degrees and not radians. I'll just change that to degrees. And now we've got a half, 0.5, times 11.7 times 28.3 times the sine of 67 degrees. And we get an answer of 152.4. But it asks us to three significant figures, so 152, and this is meters, so the area is meters squared. And that is three significant figures, 152 meters squared. Now calculate the length of AC, so this is this one here. We don't have a pair of angles on opposite sides, so we need to use the cosine rule for this question. So the cosine rule says, in this case, that this length squared, that's the opposite of the angle that we know, so that's AC squared, equals the sum of the squares of the other two sides, 11.7 squared plus 28.3 squared, minus 2 times 11.7 times 28.3 times the cosine of the angle between the sides. Now remember, this angle is opposite this side, and they are at opposite ends of the formula. So we need to put that into the calculator now, so let's do that. So we've got 11.7 squared plus 28.3 squared minus 2 times 11.7 times 28.3 times the cosine of 67 degrees. 679.03. So AC squared is 679.03. But of course we need to work out what AC is, so we're going to square root both sides. So AC is the square root of that. So let's do the square root of my answer. And we get 26 point. Now we need this to three significant figures. So we look at the third figure. This needs to go up because of the fourth figure is greater than or equal to 5. So this is 26.1. And of course the answer is in meters. 26.1, and I also like to write 3SF in brackets. Question 2. Now the triangle, calculate the length of AB. So again, notice we do not have an angle. We have the angle, but we don't have the angle and an opposite side, so we must use the cosine rule. So here, AB, this side, squared equals 7 squared plus 10 squared, so the square of the other two sides, minus 2 times 7 times 10 times the cosine of the angle between them, 73 degrees. Work that out in the calculator, 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 73. And we get 108.068. Notice I'm doing a bit of extra digits, so I don't get round off errors. Square root both sides to get AB equals, I need the square root of that now, so I'm going to do the square root of my previous answer is 10.4 to three significant figures, 10.4 centimeters, 3SF, 10.4. Question 3. So we've got a triangle. We're given these dimensions. They're also on the diagram. ABC is 106 degrees. Calculate the area of the triangle. So the area is a half times the length times the sine of the angle between them. So a half times 8 times 14 times sine of the angle 106. Calculator, a half times 8 times 14 times the sine of angle 106, and we get an answer of 53.8. 53.8 units. These are centimeters. This is an area. Centimeters squared. 3 significant figures. 53.8. Question 4. Triangle, and here's our sides. Calculate the size of the largest angle. So the first thing to remember is that the largest angle is opposite the largest side. So we'll write that down. Largest angle is opposite largest side. So we're talking about this angle here. We'll call it A. Okay, so we're trying to find that. So we don't have an opposite angle and side. So this is an unknown, so that's no good. But we need to try to find that. So we're going to start off with the cosine rule because we don't know an opposite pair. And we start off with the side opposite the angle squared, sum of the squares of the other two sides, and then minus 2 times the 4.2 times the 5.3 times the cosine of this unknown angle. And we want to work out what this is, so we can rearrange. So we're going to subtract these two from both sides now. So we're going to get 7.6 squared minus 4.2 squared, and also minus 5.3 squared. And then we're going to divide both sides by this here. So we divide by minus 2 times 4.2 times 5.3, and that's the cosine of A. And therefore, A is the inverse cosine of all that. So we need to type that into the calculator. It's easier on your calculator with a natural display. I've got a numerator, so I need to put brackets. 7.6 squared minus 4.2 squared minus 5.3 squared, and we're going to divide that by brackets, and minus 2 times 4.2 times 5.3, and we get the cosine of A is equal to, what was that number then? Minus 0.2702. Minus 0.2702. And now I need to do the inverse cosine of that to get A. So, with inverse cosine of my previous answer to get A, which is 105 point, how many? One decimal place it asks for, so 105.7. One decimal place. B, calculate the area of the triangle. So the area of the triangle, remember, is a half times this length times this length times the sine of the angle between them. So we need to use this length and this length because it's this angle that we know. So my area, I'll say area instead of A because I used A up there for the angle, is a half times the 4.2 times the 5.3 times the sine of the angle between them, which is, of course, 105.7. And down to the calculator, I'm going to use that as my answer, so I'm not going to get any round off errors. So I'm going to get 0.5 times 4.2 times 5.3 times the sine of the previous answer. And I get 10.7. Three significant figures, 10.7. 10.7. Three significant figures. Question 5. Another triangle. Calculate the length of AB. AB is opposite this side, so we know that we're going to use the cosine rule again because we don't know a side and its opposite angle. So we're going to have the cosine rule, so AB squared is equal to 8 squared plus 15 squared minus 2 times 8 times 15 times the cosine of the angle between them, which is 70. So we put that into the calculator now. 8 squared plus 15 squared minus 2 times 8 times 15 times the cosine of 70 degrees. And we get 206.915. 206.915. Again, being slightly more accurate before I square root. So AB is the square root of that. So we take the square root of my previous answer. And we get 14 point, and it's three significant figures, so we've got 14.4. And the unit's centimeters, three significant figures. Calculate the size of the angle BAC. BAC, where's that? BAC, that's this angle here. So we need to calculate that now. Don't forget we know what this is, 14.4 approximately at least. So how are we going to do that? Well, we now do have an opposite side and its angle, so we could use the sine rule for that. We're trying to find an angle A, so we'll put the angles at the top. So we're going to have A over the sine of the opposite side, which is, I beg your pardon, this side, we're trying to find the angle, so sine of A divided by the side opposite 15 is equal to another pair. We're going to use this side, 14.4 divided by the sine of 70. Now multiply both sides by 15 to get the sine of A is 14.4 over the sine of 70 times 15, and therefore let's put that into the calculator now. So we're going to get 14.4 divided by the sine of 70, and we're going to multiply that by 15 to get 229. Sine of A is, what was that, 229.86. 229.86. So my angle A is the inverse sine of that. So when we do that on the calculator, we do the inverse sine of our last answer. Oops. Our last answer, there we go. And press execute. Oh, error. What's happened here? Let's try again. Inverse sine. Oops. Inverse sine of 229.86. No, what's happened here? Let's just try this again. Okay, so 14.4 divided by the sine of 70 multiplied by 15.